Hello everybody, I'm Frank and welcome to Frank Puzzles, and this is today's hard level puzzle, and it's called Loop Count by Arbitrary. And here are the rules. Normal Sudoku rules apply, which means place the digits 1 through 9 once each in every row, column, and 3 by 3 box. Draw a one cell wide loop of orthogonally connected cells. The loop does not branch and cannot touch itself, even diagonally. A digit on the loop indicates the number of times that digit appears on the loop. So orthogonally just means that they share an edge. So basically, this is orthogonal, this is diagonal. So the loop cannot touch itself, and it's considered turning when it's basically like one of these areas, right? Um, but this is a valid example of a loop. Because this is considered turning. This is not considered touching itself, right? But it cannot actually touch itself. So, for example, if we were to, we need to figure out some way to actually get this. Let's say we remove this, and we did, oh, okay. Well, this wouldn't work because it touches itself there. But say we went, I don't know. This does not work, right? Because it touches, oh, this would not work because it touches itself twice diagonally. So this is considered touching diagonally. So a digit on the loop indicates the number of times that digit appears on the loop. So it's essentially circle. It's a circle rule, but yeah, we don't have to worry about that. It's basically however many times a digit is on the loop, it is counted that many times. Digits connected by an X sum to 10. So for example, if this was a 3, this would have to be a 7 to add, or 7, not a 4, a 7 to add up to 10. And digits connected by a V sum to 5. And so therefore, if this was a 3, or if it's a 2, this would have to be a 3. X's and V's are on borders between loop and non-loop cells. So basically, every X and every V is a border between a non-loop and a loop cell. That means you cannot have, for example, both of these be on the loop. One of them has to be on, one has to be off. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so we know all of these are boundaries. So let's just color, oops. Let's just mark them. So this is a boundary, this is a boundary, this is a boundary, this is a boundary. So this is a boundary, this is a boundary, this is a boundary. Okay, that's interesting. This is a boundary, this is a boundary. This is a boundary, this is a boundary, these two are boundaries. So what we know is if this were to become part of the loop, the problem is it has to exit out that way. So this cannot be part of the loop. So this is not part of the loop, but this must be part of the loop. And since this is part of the loop, how does it enter? It has to enter from here and exit from here, which means this is not part of the loop. And this has to be part of the loop. So it has to exit out, which exits out that way. This one can go either way. So it's either that way or it's this way, right? This one could exit this way. We don't know. Or it goes this way. We don't know. So we know one of these is part of the loop and one of them is not. These two are the same number. So this is at least 2. So at least 2. So this cannot be 9. It could be 8 down. Digits on a loop indicate the number of times a digit appears on the loop, right? We have at least 3. Hmm. I mean, technically, it could just be like that. That is a loop. It's very. Oh wait, no, it can't be because it has to include either here, 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 right? So it has to include that or that. What about this one? Oh, this one can't. This part cannot be part of the loop. If it is, it would be like here, and then it would touch itself there. So this cannot be part of the loop, which means this is part of the loop, which means it enters and exits that way. Now, same thing here. If this is, say this is not part of the loop, if this is not part of the loop, this has to go back here, and then that touches itself there. So therefore, this is the part of the loop that cannot be part of the loop. So therefore, this is part of the loop. This has to continue out this way, actually. So this, we know that's part of the loop. These cannot be part of the loop because it would touch itself. Same here. Okay. What happens if this was part of the loop? If this is part of the loop, both this and this would have to be part of the loop. But then how does it enter? I guess it could go... Well, the problem is this is not part of the loop if this is part of the loop. So if it enters this way, then goes out this way, the problem is it would have to double back, and that's not possible. So this can't be part of the loop, which means these two are part of the loop. Therefore, this one has to enter here and exit here. So therefore, these two are connected. This can no longer be part of the loop, therefore it's not part of the loop, therefore that is the part of the loop. One of these two is, we don't know which. This one has to go essentially here. So these are not part of the loop. Oops. These aren't part of the loop. These aren't part of the loop. It could go down here. Yeah, that's fine. Can it avoid this? I guess, because it goes something like that. That seems possible. So it could go either here. It goes either here or here. We don't know which. This could go this way. It would have to go something like that. Or it goes something like this. Right? So either way, it's either this or it's this. But we don't know which. This one either goes here, which connects to the yellow, or it could go, this could also be orange, or this could be orange. So orange goes either one of these two ways, and then goes down here, right? The yellow would have to go that way. Pink and orange. Obviously, if it's orange, it can't be pink, and it would have to be red, so it would have to go something like this. Something like that. Right. So let's make this the... Well, it doesn't mean... The yellow could be with the red, so we don't know. Obviously, whichever one it is here, it has to be the opposite here, right? So if this is pink, this can't be red, so it has to go this way, right? So this is pink. And then it would have to go something like that. Oh, but what happens if it does that? So say, okay, say well, it could go here, right? But the problem is, okay, so if it's pink, it can't be orange, right? So it would have to be yellow. But the problem is if this pink and if this is a pink, this also has to be part of the loop, right? So if it's pink, if pink is part of the loop, then this pink is part of the loop. How do you connect here, right? Because this has to connect yellow this way, right? Because otherwise it can't really go here. You can't go here and then double back. You can't go doubling back here. So this one has to connect this way. And if you have pink, orange cannot be the case. So therefore, you would have to connect here. You would have to go down here. And how do you actually connect with the yellow or the pink? You can't, right? Because you have to either go this way or this way, but the problem is you can't do both. Therefore, we know this is not part of the loop, This is not part of the loop. This has to be part of the loop, which means this is not part of the loop. This can't be part of the loop because it would touch itself if it went that way. So therefore, it could go this way, it could go this way. We don't know. But this is part of the loop too. And it can't go down. So therefore, this has to it can't enter this way, right? Because if it enters this way, it would be touching. Well, I guess it could enter this way. It can't. It could be this or this, right? It can't go here and then go back here because it touches itself. So therefore, this is always part of the loop. Does orange work? I guess so, yeah. You could go something like this, or you could go something like this, right? So orange does work. So the question then becomes, how do we get which one of these works? They both seem to work okay, right? So can you go this way is the question. No, you can't go because you touch itself, right? So this is not allowed, this is not allowed. Therefore, it must go this way, which means these two can't be. This can go either here or here. So either way, these two are valid, which means it has to go up here because none of these can be valid. Because it can't touch itself, so it would have to go here at least. So it could go here, it could go here, it could go here. So we have all 9. We have 8 of the digits, at least. Ooh, excuse me. So we have 8 of the digits, which means it could be 1 through 8, which would be 45 minus 9. How many digits do we have already on the loop? So this is 1, 2, 3. This is 8 here, right? Plus 3 is 11. Plus 2 is 13. Plus 4. So 8 plus 3 is 11. Plus 2 is 13. Plus 4 is 17. This has to be... Let's just do these 5. So 17, 22, 23, 27, 28, 29, 30, 31, 32, 33, 34. So it has to be longer than that because we know we have at least 8. Oh, interesting. If it goes to orange, okay, so if it's orange, it has to go here. So it goes either here. Okay, so therefore we can't, and you would. So if it's orange, you cannot have a something on the loop here. So therefore, this is at least. Therefore, you would only have the numbers 1 through 8 here, and therefore this would have to be a 9. If you go this way, you can never go into box 5 in the loop. So then you don't have a number that way. You don't have all 9. You can't have all 9 digits be on the loop in box 5. Therefore, this is a 9, and we know this is 1 through 8. No 5. There has to be a 5, actually. But this can't be 5. 6, 7, 8. So we have 1, 2, 3, 4, 5, 6, 7, 8 on the loop. So that means it must be 36 digits. And this is 1, 2, 3, 4, 5, 6, 7. This one, yellow, can be either of these two. So this, okay, so then let's count up the number again. Then this is, okay, so this is 7 plus 3 is 10. This is 1, 2, 3, 4, 14, 17, 20, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. So we have to add 2 more, which means we have to go here. So it has to go here, which means this is not, right? So then this adds up to 36 either way. So either if it's orange or if it's yellow, either yellow, it has to add up to 36 digits, right? Because we know the loop is 36 now, because this can't be 9. So this can't be 9 either. This can't be 2 because we know one of the 2's is here. One of the 1's is here, so 1 can no longer be on the loop. So this can't be 2. This has to be at least 3. So 3, 4, 5, 6, 7, 8. So this is 2, 3, this can't be 8. 2, 3, 4, 5, 6, 7. It can't be 5, obviously, because it can't add up to V on the loop. So we know 1 and 2 are already here. Actually, one of each digit is already here, right? This cannot be 1, so this has to be 2 through 8. This then becomes 2, 3, or 4. This has to be 1 and 9, because 1 is already taken care of here, and 9 is never on the loop. So this is 2 through 8. Therefore, the rest of the puzzle cannot contain a 2 either on the loop. No 1, no 2, no 9. So this is 3, 4, 5, 6, 7, 8. 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 And we don't know if it's orange or yellow. So one of 2 is here. All of 2 is accounted for. This is one of 3, one of 3, one of 3. No, sorry. We have 1, 3 here. We have 1, 3 here. Therefore, this cannot be both 3's. So this cannot be 3. This is 4, 6, 7, 8. This can't be 7 then. I think this has to be... Either these 2 are the same, or these 2 are the same, and they're on the loop. So none of those can be 3 either. Interesting. Where is the 8? The 8 has to be either here or it's here. This is 5 out of the 3, 4, 5, 6, 7, 8. So this can't be 5. This can't be 5. So therefore, this is 2, 3, 4, 6, or 7. This is 2, 3, 4, 6, or 7. These can't be 5. These can't be 5. This is 1, 2, or 3. This can't be 9. The 9 has to be one of these 2. The 9 has to be one of these 3. This can't be 9. We know 8 cannot be in the gray. Well, that's not true. It could be here, right? Because if the orange is not on the loop, the 8 has to be on the gray in one of the gray cells there. This can't be 9. This can't be 9. This can't be 1. So 1 is one of these 3. That's not helpful. This cannot be 8. So 8 has to be one of these two. Does it? Not necessarily. Because we cover all 9 columns, so 8 doesn't have to be in that column necessarily. This is 2, 3, 4, 6, 7. This is 2, 3, 4, 6, 7. This is 2, 3, 4, 6, 7. 10, this is a 10. Okay. Five has to be here. So we have 2 of every number accounted for already. Therefore, this can't be 3. Could go this way. Could go this way. We're just drawing in the lines. This probably doesn't help anything. I don't know, makes me feel a little better. um, hmm. What else do we have? Well, I don't know that part. Okay, this can't be obvious. None of these can be, right? So none of these could be. None of these can be. So if this is part of it, that has to be an 8, right? What does that mean, though? So again, this is 1, 2, 3, 4, 5, 6, and 7. This is 1, 2, 3, 4, 5, 6, 7. So we have 36. This is at least 4 and maybe 5 in this box. This is 5 in this box. This is 7 in that box, obviously. So if this is 8, if it goes this way, it's 8. Therefore, it eliminates anything here. Therefore, one of these is 8. One of these is 8. Actually, yeah. And one of these is 8. That doesn't really tell us much. We have 3 here, 3 here. That's not helpful. The box narrowing seems to be pretty helpful. Hmm. So 7 in this would be 5, 1. So it's 13. This is 5, 18. This is 5, 28. Wait, that's too many. 7 plus 5. Plus 5, plus 1, plus 5, so that's 15. 15 plus 7, 23. This is 4, 27, plus 4, 31, plus 5 is 36. Okay, where do we go from here? 9 can be any of these. 9 cannot be here, but it could be any of these 4. We know 1 and 9 cannot be on either side of this. So this has to be 2, 3, 4, 6, 7, 8. Therefore, this and this can't be 6, 7, or 8, so this can't be 2, 3, 4, so this can't be 6, 7, 8. Oh, maybe that's helpful. This has to be 1, 2, or 3. So if this is on the loop, okay, what does that mean then? So first of all, okay, that's interesting. So if this is on the loop, it has to be 4, 6, 4, 6, right? Because we already have 2 of 2, 1, 2, and 3, or 2 of 2 and 3, and 1 of 1 already. So then this would have to be 4, 6, 4, 6. So then you would have 4 twice on the loop. So this could not be 4. What about if it's this way? So then this would be 1 if that's the case. If it's this way, obviously this can't be 1. So this is 2 or 3, 2 or 3 with 7 or 8, 2 or 3, 7 or 8. That's possible. What we know is if this is 2, 3, this has to be 4. So there's no 4 in that column. Because if this is 2, 3, this has to be 4 then. This cannot be 3 either, right? Because we know we have 1, 3 here. So this can't be 3, which means this can't be 7. This could be 4. That could be 4. We don't know which. So if this is part of the loop, this cannot be 1, so it's 2 or 3 with 6 or 7. No, 7 or 8. 2 or 3 with 7 or 8 with 7 or 8. That's certainly possible. 8 would have to be part of this if it's part of the loop. So if that's 7, this would have one of these would have to be 8. This could be 1 or 4. 4, 6, 4. If it's 7 or 8, then it doesn't really change anything. Let's see. What we know is 2. Okay, this is interesting. 2 out of 6, 7, and 8 have to be here. There's also a 6, 7, and 8 here. So that's 3 out of 6, 7, and 8. So that's 3 sets, 3 digits, which have to have 3 cells which contain 3 digits 6, 7, and 8. Therefore, the rest of the column cannot contain 6, 7, and 8. So now we have 1, 2, 3, 4, 5, and 9. This is 1, 2, 3, 4, 5, and this could be 9. Interesting. So this cannot be 8. So if there's an 8, it has to be here, or this is 8. But we don't know which, right? Interesting. So if this is, okay, so if this is 2 and 3, this becomes 4, 1. Then this becomes 2, 3 with 7 or 8, because it can't be 4, 1 anymore. But if this is 1, 4, this is 2, 3, 2, 3, which means this is 4, 6, 4, 6, 4, 6. Oh, so that's interesting. So if this is 2, 3, interesting. Okay. So if this is 4, so say this was part of the, say the yellow was part of the loop. Then this has to be 4 and 4. And then this would be 6 and 6. This would be 1. This would have to be 2 and 3 here. So that eliminates 2 and 3 here. 4 can no longer be on the loop. So this has to be 6 and 6. And this is 4. Right? Because we have 2 4s here. We have a 4 here. And we have a 4 here. So that's 4 4s, right? This obviously can't be 4 and 6, cannot be 4 and 6 if that's the case. So this can't be 4 or 6. Then we have a 7 or 8 here. So far that all looks kosher, right? I think, okay, so that's that way. What if the orange is part of the loop? Then this cannot be 1. This is 2, actually can't even be 3. Sorry, it can't even be 2. Because we know 2 has 1 here, and 2 has 1 here. So this one cannot be 2. Therefore, this has to be 3. That would be 2. So then you'd have 3, 2. This would have to be 8, 2, 8. Right? So the 8 is either here or it's here. And then it's here or here. Okay, so that's good to know. So therefore, this can't be 7. This can't be 3. This can't be 7. So the 8 in row 3 has to be one of these two. Right? Therefore, this cannot be 8, which doesn't really tell us much. But so if the orange is part of the loop, this would be 8 and 8. So then this would be, so this, okay, this would have to be 2, this would be 3. So this is 4 and 1, which means this is one of 2 or 3, 7 or 8. This would have to be 8, 2, 8. So this could not be 8 and 2, so that can't be 8. This can't be 8. These two are out, not on the loop. The 8 would be here, therefore this can't be 2 and 8. This still could be many things. These obviously couldn't be 8. Therefore, if this was 8, this would eliminate 8. Well, that could be the case. So 8 is one of these two then, if that's the case. 2 is outside the loop. 3 is no longer in the loop, so this can't be 3. This can't be 3. It has to connect this way. So therefore, this is 4, 5, 6, 7, 8. The 4 is on, well, that's already counted for, so this can't be 4. 8 is one of these two. 8 is one of these. 4. Neither of these can be 8. This can't be 2. So this is part of the loop, which means this cannot be 1, 2, or 3. So this becomes 4, 5. It can't be 9, so this is 4 or 5. These can't be 2. So it goes either one of those two ways. We have this can't be 2 or 3. This can't be 2 or 3. 4, 5, 6, 7. So this can't be 8. This all seems kosher right now. This can't be 3 because we know the 3's here and the 3's here. So this can't be 3. Which means this is 4, 5, 6, 7, 8. So this can't be 4, 5, 6, or 7. So therefore it's 2, 3. This has to be 7, and this has to be 3. Which means this is 4 and 6. This is 4 and 6. So this can't be 4, so this is 5. No 3, 4, or 5. So this is 1, 9, 1, 9, which forces this to be 2. This all seems kosher, so this has to be 8 then, which makes this 2, which makes that 8. Okay, so we know then this has to be 8 and 2, if that's the case. So, okay. So we showed... So this cannot be 4, because if this is 4 and 6, this becomes 2, 3, 2, 3, which makes this 1, 4, so the 4 has to be on the loop. So this can never be 4, this can never be 6, this can never be 4. We've also shown that this has to be 6 and 8 to be 2 and 3, right? This one we still don't have enough information about, though, so we don't know that one. But yeah, let's just show. So if the orange is the loop, so this would have to be 4 because it cannot be anything else. So therefore, these would be 6, this would be 1, this could not be 4, so this would have to be one of 2 or 3, that's 2 or 3. This has to be 4 and 6, and the 6 would have to be on the loop because the 4 is already part of the loop twice, and then here, and then here. So that's 4 on the loop. This has to be 6. Obviously, this could not be 6. This is 2 or 3 with 7 or 8. This would have to be 8. So that's interesting. This is all kosher, though. This cannot be 4 and 6. This can't be 4 and 6. This can't be 4 and 6. So we have a 2, 3, 7, 8 here. This can't be 1 or 9. It can't be 2, 3, 7, or 8. So no 2, 3, no 2, 3. This can't be 4. Therefore, this would have to be 4. So no 2 and 3. And this would be no 4. So this would be 1, 5, or 9. This has to be on the loop. It cannot be 1 or 9. So this has to be 5. This all seems kosher. Okay. So this would be a 4 if these are 4s. What happens if we have the 2 and 3? So say these were not on the loop, therefore this is on the loop, therefore this would have to be a 3. This would be a 2. This would be 8, 2, 8. This would be 4 and 1, which would force this to be this cannot be 2 and 8. This can't be 8 and 2. This can't be 8. Therefore, this is 3, 4, 6, 7. This would have to be on the loop. This could not be on the loop. So this would have to be on the loop. It cannot be 2, 3, 4, 1, or 9. So this would have to be 5. This can't be 2, therefore this is 2. Okay, so this is also 2 or 4. So we know this is 2 or 4. So 3, 7 is always on the loop, on this set, right? Yeah. So therefore this cannot be, so either this is 2, 3 with 7, 8, or this, sorry, 2 and 8, 3 and 7, or it's 3, 7, 4, 6. So 3 can never be on the loop. One of these two must be on the loop, and it must be 5. Because if 4's here, then it's on the loop. This cannot be 4. And it cannot be 2, obviously, because we already have 2 taken care of. So 5, I think, has to be one of these two, which means this can't be 5. Right? Because it can't be the other two. So if it's 4, quote unquote, if this is 4, that means 4 can't be on the loop. This is 2, 3, 2, 3, which makes this 4, 6. So this can't be 4 and 6 here. So this becomes 2, 8, 3, 7. Therefore, this cannot be 4 and this cannot be 4. So one of them, so this one has to be 5, if that's the case. So one of these is on the loop, though. If it's 2 and 2, and this becomes 3, this is 4, 1, which makes this 2, 8. So this is 4, 1. This is 3. This is 8 and 8. So this can't be 2, 8. So this has to be 3, 7, 4, 6, which means this can't be 4. So this is 2. This can't be 4. So this has to be a 5 again. So 5 is one of these two. We don't know which. Can this ever be 2 and 4? No, because we have 2 and 4. So one of these is 2, 3, or 4. One of these is 2, 3, or 4. This is 2 or 4, so we have 3 digits now that are 2 or 4, 2, 3, or 4. 3 cells in column 5 that are 2, 3, 4. Therefore, 2, 4 cannot be in the rest of the column. So this can't be 2, 4, this can't be 2, 4, this can't be 2, 4. So we have a 1, 5, 9 triplet there, which works. Okay. So this is the same as that, which is fine. Can this be 4 twice? Then this would be 2, 8, 2, 8. This would be 4, 1. This would be 2, 3. Maybe. Let's see. So either this is 8 or this is 8. They don't see any other cells. Yeah. Let's see. So that 10's taken care of. This could be 2, 3, 4, 6, 7, 8, 9. So we know there's a 5 here. We know there's a 5 here. We know there's a 5 here. So that's 3 5s. But the problem is that 5 could be in a lot of different places. So it's not too helpful there. If this is 4 and 6, so let's try that. Then this would be 2 and 8. This is 8. This becomes 4 and 1, which means this is 2 and 3, which means this is 8 and 2 and 8. Which means it connects this way. It cannot go both of these. So orange cannot be here. If it tried to go orange, 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 this would have to be 1 or 9. Because this would have to be the 5. And 1 or 9 is no longer allowed because there's 9's never allowed and 1 is already here. Okay. So actually, let's make sure we do that for all instances. We know this cannot be orange. So the yellow would have to go here. If it's orange, it has to go here. So again, we tried this 4, 6, 4. This is 2 and 8. This is 8, obviously. This is 4, 1 then. This becomes 3 and 2, 8, 2, 8. So this has to be 5. This cannot be 2 and 8. Therefore, this is 2. There's no 2. There's no 8 here. There's no 2. This can't be 8. This can't be 8. These can't be 3 anymore. So these can't be 7. Can't be 5, obviously. This is 8. This can't be 4. This can't be 4. None of these can be 4. This can't be 3, and this can't be 4. No 2, 3. No 2, 3. So we have a 5 here. This cannot be 3 because we have a 3 here, we have a 3 here, and we have a 3 here. No 2, 5, or 8. No 8, so there's no 2. This can't be 3. This can't be 2, so this can't be 8. No 2 or 8 here. The 8 can't be here, and the 8 can't be here, so the 8 could be here. This can't be 2. This can't be 4, this can't be 4. So 4 is one of these two, so this can't be 4, this can't be 4. This can't be 4. The 4 is here. We have a contradiction. This is a 4 on it. These two are 4s. So these, and this one has to be a 4 because 3 is no longer on it. So because of that, we already have 4 4s. That one, this one, and these two. But there has to be a 4 on this column somewhere. So that's 5 4s. So that's not allowed. So this upper corner here cannot be a 4. So this cannot be 4, which means this can be 6, 7, or 8 still. Hmm. Oh, that's interesting. Right. So, if this were 4 and 4, and the yellow is part of the loop, this becomes 6 and 6. This is 1. This has to be, again, 2 and 3. So therefore, this becomes 4. This is 6. This is 6. So 4 is already considered twice on the loop. And then it also has to be here, and then it also has to be in one of these columns. Therefore, this cannot be 4. Therefore, it has to be 3 in that instance. So either way, we know where the 3's are, right? Either this is 3 and it's on the loop, and therefore we have 1 here, 2, and 3 already on the loop. Or this is 4 and 4, which makes this, and one of these is 4 and one of these is 4. So therefore we already have 4 on the loop, therefore this can't be 4, and therefore it has to be 3, 5, 6, 7, and 8 here on the loop. So 3 is either here, here, and in the column 8, or 3 is here, and then in the box 7, and then column 8. Therefore, the rest of the loop cannot contain a 3. So this cannot contain a 3. This cannot contain a 3, which means this can't be 7. This could be part of the 3. This could be part of the 3. This could be part of the 3, but this cannot be part of the 3. Does that make sense? If this is 2 and 3, we still have 4 possible anywhere in the loop. So there's that. Hmm. 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 So I think, what happens if this is 2, 3? Okay, so, right. If this is 2, 3, 3 is on the loop, therefore this has to be 4, 5, 6, 7, 8. If this is 4, 4 on the loop, the 4 can no longer be on the loop, so this is 3, 5, 6, 7, 8. So 6, 7, 8 cannot be, has to be in one of these 5 squares. So the cannot be part of the rest of the squares. So then this has to be 1, 2, 3, 4, 9. This is 1, 2, 3, 4, 9. So we can remove, let's remove the outer ones because it's kind of confusing. Right, so then this has to be 6, 7, or 8. Because this, yeah. So then 5 is one of these two. That doesn't tell us anything though. This is 2, 3, or 4. What if this is 4? If this is 4, well, That has to be 6. Which means this can't be 4, so this becomes 2, 8, 2, 8. That's a 3. This becomes 4 and 1, so this is 2, 8, 8. So obviously this is part of the loop, so this has to be 5. This obviously can't be 8 and 2 and 8. This can't be 6, so now this becomes 7, 3, 7. So far it all seems okay. This can't be 8. This can't be 8. None of these can be 3. This can't be 4. This can't be 4. This can't be 2, 5, or 8. This can't be 3 or 7. Which means this can't be 3 or 7. This can't be 4 or 6, so this can't be 4 or 6. This obviously can't be 7 or 8. This can't be 2 or 3. This can't be 2 or 3. So far it's looking okay. Hmm. 4, 4. Obviously there's a 4 in somewhere else, so this can't be 2. This can't be 2 or 8. This can't be 4. This can't be 2. This can't be 2, right? 3, 4. So this can't be 7, because this can't be 3 here. This can't be 4, therefore this becomes 3 and 7. So this is 4, 6, and 4, 6. That seems fine. So this is 2. This all seems kosher. This can't be 7. This can't be 7. This can't be 4 or 6. No 6. 7 or 8. This all seems fine. This can't be 1. This can't be 1. No 4, no 4, no 3. Obviously, this can't be 2, so this is 9. This is 2. All seems fine. This can't be 2. One of those is 2. One of these 4 is 2. We don't know which. Yeah, seems kosher. Right, inbox. Oh, that's one thing we know. So one thing we know, okay. Yeah, that's one thing we do know. Where is the 8 in boxes 3 and 9? It has to be on the loop because we know either box 1 doesn't have an 8 or box 5 doesn't have an 8. Therefore, in box 3, it's in one of these 4, which is column 7, column 8. And in box 9, it's in one of these 4, which is column 7, column 8. Therefore, there cannot be a 8 in column 7 or 8 because those are eliminated by these 8s. Therefore, this cannot be 8. This cannot be 8. Where is the 8 in box 6? It has to be in one of these spots. So therefore, this is 8. This cannot be 8. This cannot be 2. It's a very small thing, so I don't know if that helps anything very much, but at least we know, right? So we went through the 4s and 6s, and that seemed okay. Sheesh. what happens if this is 7? I don't know if this changes very much. Therefore 8 has to be here, therefore this can't be 8. So this must be 8, 2, and 8. Which means this can't be 8 or 2. This cannot be 2 and 3, so this is 4 and 1. Which makes this 2 and 3 and 8 and 2 and 8. So this can't be 7 or 8. 8 is on the loop, so therefore this is a 5. It's orange loop. This can't be 2 or 3. This can't be 2 or 3. This can't be 3 anymore, so no 3, 8, no 3, 8. No 4 in box 8, so this has to be 3 and 7, which means this can't be set. This has to be 4 or 6. This can't be 7. This can't be 1, 3, or 4. No 1, 3, or 4, which makes this 9, which makes this 2. This has to be 9. This has to be 1. So therefore, this is 9. This has to be 2. It seems okay. No 2 and 8. This can't be 1. This can't be 1. This can't be 8, so this can't be 2. This can't be 3, so this can't be 7. So it's 4, 6, 4, 6, which means this can't be 4, 6, which means this can't be 4, 6, which means this can't be 4, 6. No 3, 7, obviously. This can't be 2, so this is 3. This is 7, which makes this an 8. 2 and 9 cannot be here, so this has to be 2 or 9. This can't be 2. This can't be 3 and 7. 8 is obviously one of those two. So this is all kosher. I mean, none of these are 2. This can't be 3. This can't be 3. Therefore, this must be the 3. This can't be 4 or 7. So this is 5 or 6. This is 5 or 6, which means this can't be 5 or 6. That can't be 5 or 6. This can't be 3, obviously. 2 is one of those two, so this can't be 4. This can't be 4. No 2 or 5. This can't be 8. So 8 has to be here, right? Because where is it in box 4? It can't be here. Can't be here. So it has to be here specifically. This can't be 8 then. These two can't be 8. These can't be 8, therefore this is 8. So no 8s, no 8s. This cannot be 1, 2, or 3. Cannot be 7 or 8. So this is also 4, 5, and 6. That's interesting. This can't be 7. This can't be 7. Therefore, 7 is one of these two. This can't be. This has to be. This could be 1, 4, or 7. Can't be 7. So it's 1 or 4. This can't be 6. So this is 5. This is 6. This can't be 4, so this is 1. We have a 4, 7 pair, so this can't be 4. This can't be 4. This can't be 4. 2 has to be here because there's no other place. This is all looking good, kosher. 3 has to be here. This can't be 6. So it's 1, 5, and 8. Therefore, this is 4 and 6, which he has. He's 4, 6, 4, 6. So this has to be 5. This can't be 5. This can't be 5. Therefore, this is the 5. This is obviously 1, 9, 1, 9. And we have 3, 4, and 6. So therefore, this is 3. This all looks kosher. I might be just going down the correct path and just like... This can't be 5, so it's 6 or 7. We know one of these is 4. We know one of these is 4. We have a 4 here, so that's 3. We don't know about that, though. How many 6s do we have? We have 1, 2, 3. So this, what is this? This is either 4, 6, or 7, right? What is this? This has to be 4, 5, 6, or 7. We already have 4 5s, but we need, no, 5 5. So this cannot be 5 here. So this becomes 4, 6, and 7, which means this is 1 and 5. So this can't be 5. This is 1. This is 5. I might just, yeah, this might be the correct path. So we know 4 is here. 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 Therefore, this cannot be 4. Therefore, this is 6, 4, 6, 4. How many 6s do we have? We know 3 6s here. 1 6 here. 2, 3, 4. This can't be 4, so this is 6. This is 4. This is 6. This can't be 4. This has to be 4. This is 1. You have 1 4, 2 4, 3 4, and 4 4. So this has to be 7. This is 4, which makes this 7. This is 2 5 6. We have 1 5 2 3 4, and 5. 8 seem to be valid. 7s, we have 1 2 3 4 5 6 7. Yeah, so this is all valid. Okay. I was hoping to find a contradiction. I did not. So we going back looking for more contradictions. There's gotta be a better way than this, than just trial and error, right? I don't know. Okay. Well, we're gonna have to trial and error again, too. 4 8 4 8 6 6. This is 1. This has to be 2 and 3, which makes this 4 6 6. So this can't be 6. This cannot be 6. No 4 6. No 4. Oh, we have a 2 3 2 3 pair. Ah, that's the contradiction. That's what I was looking for. So if we have 4 1 here, this is 2 3 2 3. This becomes 4 6. So this can't be 4 and 6. Therefore, this is 2 3 7 8 2 3 7 8. But we have a 2 3 2 3 pair here. So this cannot be 3. So therefore, this has to be 4 5 6 7 and 8. But we already know we have 2 4s on the loop. We have a 4 here, and we have a 4 here. So that's 5 4s on the loop, which is a contradiction. Therefore, the yellow cannot be part of the loop, and therefore we've shown then that it has to be, the orange has to be part of the loop. So the yellow cannot be the loop. So we just remove that, and the orange is part of the loop. So the orange is now part of the loop. So now we can just, oops, draw in the boundaries. So now we know this has to be 3 then, because it can't be 1 or 2, and it can't be 4, because this can't be 1, 9. So this is 3, this is 2, this is 8, this is 2, this is 8. And then now we just go down the route that we had already gone down. So this is 2 and 8, this is 8. The thing is, this actually still could be 6 here. So this one we don't know. So this can't be 8. Obviously, none of these can be 8. This can't be 2 and 8. This can't be 2 and 8. So this is 3 or 4. This can no longer be 3 in this box because we have 3 3s, 1 here, and 1 on this column. Therefore, this is 4, 5, 6, and 7. This can't be 4, so this is now 3 and 7. So this is 4 and 6. So this can't be 4. This is 2. This has to be a 5 because it's on the loop. So the 5 is no longer here. This can't be 7. This cannot be 7. This can't be 7. This can't be 7. We can't have 1, 3, or 4. No 1, 3, or 4. This can't be 2, so this must be a 9. This has to be 2. This can't be 9. No 2 and 8 here. This can't be 8, so this can't be 2. No 8 here. This can't be 8. This can't be 2, so this can't, or it cannot be 2. So this can't be 8. Therefore, this can't be 8. Therefore, this must be the 8. So this can't be 8. Where is the 8 in box 4? It has to be on the loop, so this is 8. So this can no longer be 8. This also can't be 4. This can't be 2 or 3. This can't be 2 or 3. There's no 2 here. This can't be 1, so this is 9. This is 1, so no 1's here. This can't be 4, 7. This can't be 7. One of these is 3, so this can, and one of these is 4, 6. So this cannot be 3, 4, 6, or 7, which means this is 1 or 8. This is 2 or 9, this is 1 or 8. This is 2 or 9. 3, it's either 3, 7 here, or this is 3. So the 3 in box 3 can never be in any other cell. So it's either this is 3, 7, or if this is 4, 6, this is 3. So this can't be 3. This can't be 2. We have a 1, 9 pair here. This can't be 3. This is 4, 5, 6, 7. This is 4, 6, and 7. So 5 is one of those two. 5 is one of these. We have a 5 here. This could be 4, 5, 6, 7. It cannot be 3. So 3 is one of these two. So it's 3, 4, 5, 6, and 7. This can't be 2. So this is 2, this is 2. One of these is 2. This has to be the 9. There's no other place for 9. So this can't be 9, so therefore this is 9. This can't be 9, so therefore one of these is 9. This can't be 3. Can't be 2 and 8. Can't be 9. So this is 1, 4, 5, 6, and 7. This can't be 3. It could be 9. It could be 2. Can't be 8. So 8's one of these two. 8 cannot be any of these two, so therefore this must be 8. 8 is one of those two. Let's see. Seven has to be one of these three, so this can't be 7 because we have a 4, 5, 6, 7 quad. This has to be 1, 3, and 9. Obviously can't be 9. This can't be 3, so this is 1. This can't be 1. This can't be 1. So it's a 3, 9, 3, 9. This is 4, 6, and 7. So 7's one of these two. This can't be 5. 7's one of these. The other 4, 5, or 6 is here. We have a 4, 6, 7, 4, 6, 4, 6, 7 triplet in row 6. So none of the other cells can be 4, 6, or 7. This can't be 4, 6, or 7. It could be 1, no 2. Could be 3, could be 5. No 4, 6, or 7 here either. So this is 1, no 2, 3, no 4. Could be 5, no 6 or 7. It could be 9. So this can't be 1 or 9 because of these pairs. So this has to be 5. So this can't be 5. These can't be 5. Where is the 2? The 2 has to be here. So this is a 2, which means this can't be 2. So then this becomes a 2, 9 pair here. So this is 2 and 9. Because we have a 2, 9, we have a 2, 9. Where is it going to be here? It can't be here. Can't be here. So 2 is one of these. This can't be 5. This can't be 5. So we have a 4, 6, 7 triplet in row 5. Therefore, the 5 has to be here. Which means this can't be 5. We have a 4, 6, 7 here. We know there's a 4 in here. We know there's a 4 here. So 1 4 here, 2 4 in here, third 4 here, and fourth 4 here. Therefore, this cannot be a 4. So this has to be 6 and 7. So this has to be 3 and 4. Therefore, none of the other cells in box 6 can have a 6 or 7. So this is 1 3 4, 1 3 4. Mm-hmm. Let's see. One of these two. We have 1 7 amongst box 4 and 5. Right? Because only one of these can be 7. So that's amongst box 4 and 5, we have 1 7. There's already 1 7 that's taken out from box 1. Therefore, all the other boxes must have 7. So this must have a 7, this must have a 7, obviously this must have a 7, this must have a 7, and this must have a 7. Because this must be 7, none of these two can be 7. Therefore, this has to be the 7. So we were solving the correct path, and it was 7 3 7. So this can't be 7, this can't be 7. This can't be 3 anymore, so this is 4, this is 6, this is 7, this is 3. So this can no longer be 3. Where's the 3? It can't be 3 here, so this is 1, this is 4, this is 3. This can no longer be 3. These can't be 3, therefore this must be 3. So this becomes a 5 6 5 6 pair. Yeah, we were solving essentially the correct thing. This can't be 4 or 7, so this has to be 1. This can't be 6, so this is 5. This is 6. This can't be 1. This is 4 and 7. This can't be 4, and it can't be 6. So this is 1 5 8 triplet. Therefore, this must be a 6. This can't be 4 or 6, so this is 5. This can't be 5. This can't be 5. Therefore, this is a 5. And now we're solving what we were solving before. So this can't be 5. 4, 6, 7. These can't be 5. It's 3 with 4, 6. This can't be 3. Therefore, this is a 3. No 4, obviously. So how many 4s do we have on the loop? We have 1, 2, 3, 4. So this cannot be 4. So this is 6, this is 4, this is 6, this is 4. This can't be 4 or 7, so this is 6. This can't be 1, so this is 9. This is 3, this is 9. This can't be 6. The 7 has to be here, so this is 7. So this becomes a 4 6 pair. This can't be 6, so this is 4. This cannot be 1 9, because this would lose all possibilities, so therefore this is 8 and 2. I probably should have been able to figure that out earlier, but anyways. This can't be 8 anymore, therefore this is the 8, and now we're just doing Sudoku. Yeah, because all the other stuff is taken care of, pretty much. This can't be 6, this is 7, so makes that 4, makes that 7. None of these can be 7. This has to be 1 and 7, so therefore that's 7, and this is 1. This can't be 5, this is 1. This is 5, this is 1 because of that 9, so this has to be 9. This is 2 and 6. So this can't be 2, so this is 6. This is 2, which means this can't be 2, so this is 2. This can't be 6, so this is 5. This is 6. This is 4. This is 6. We have 5 and 9. This can't be 9, so this is 5. This is 9. This is 3 and 4. No 4, so this is 3. This is 4. This has to be 1, and this is 7. And that's the solution. And I hope you enjoyed this solve. And I'll see you next time on Frank Puzzles. Take care.